Okay, we left off here on the last video. We broke this original integral up. We said let f of x equal the absolute value of 2x minus 1, which is really a piecewise function. So we graphed this, and then what I did, first of all, I did the limits of integration from 0 to 1/2, because that's this piece of the graph underneath the curve, and this part of the line here is when x is less than 1/2 would be negative 2x plus 1. So that's where I came up with this. And then, see, I did this wrong. This should be 1/2. And then from 1/2 to 2, the graph is going to be 2x minus 1. So this part of the graph. So hopefully that makes sense. It's going to be much easier to integrate these two integrals than the original one that I had. So let's go ahead and do that. Let's evaluate this now. So the antiderivative of negative 2x plus 1 would be negative 2x squared over 2 plus x. And I'm going to integrate that from 0 to 1/2 plus the antiderivative of 2x minus 1 would be 2x squared over 2 minus x. And we're going to integrate that from 1/2 to 2. So first let's plug in 1/2. So this would be negative 2 times 1/2 squared over 2 plus 1/2 minus, if I put 0 all the way through there, that's just going to be 0, plus, let's integrate this one, or let's plug in the limits of integration. So this would be 2 times 2 squared over 2 minus 2 minus, and then I'm going to plug in 1/2 all the way through here, so 2 times 1/2 squared all over 2 minus 1/2. So now I just have to calculate all this. So these 2's cancel out. 1/2 squared would be 1/4. There's still a negative sign there, so this is going to be negative 1/4 plus 1/2. Plus, these 2's cancel out. 4 minus 2 is 2, minus, this would be 1/4 minus 1/2. Distribute the negative all the way through. So I've got negative 1/4 plus 1/2 plus 2 minus 1/4 plus 1/2. So 1/2 and 1/2 is 1, plus 2 is 3. So I have 3 minus 1/4 minus 1/4 would be 1/2. So this is going to be 2.5, or 5/2. That would be the area underneath the curve here. Okay, example 3 here, we're going to find the area of the region bounded by the graph of y equals 1 over x. The x-axis, the vertical lines, x equals 1 and x equals e, as shown in the figure. So we're going to find the area underneath the curve of 1 over x. The limits of integration are going to be x equals 1 and x equals e. Remember, e is roughly 2.718. So we're finding the area right here. Okay, to do that, we're going to do the integral from 1 to e of 1 over x dx. Okay? Now, let's go back and talk about the derivative, the natural log of x. If I ask you to take the derivative of natural log of x, that's going to be 1 over x. Okay? And so if I start with 1 over x and take the antiderivative, I'm going to end up back at the natural log of x. So this, when I take the antiderivative of 1 over x, this is going to be the natural log of the absolute value of x. I got to make that the absolute value of x because that has to be positive. That's just the definition of a natural log. And we're going to integrate this from 1 to e. So this would be the natural log of the absolute value of e minus the natural log of the absolute value of 1. Well, the natural log of the absolute value of e is 1, and the natural log of the absolute value of 1 is 0, so the area is going to be 1. Okay, the next theorem we're going to talk about is the mean value theorem for integrals. It states, if f is continuous on the closed interval from a to b, then there exists a c in the closed interval a to b such that the integral from a to b of f of x dx is equal to f of c b minus a. Okay? So in other words, if this is f, and we were finding the area underneath the curve here, it would be this in yellow here, right? Okay. So in yellow here, I have define the area of the yellow. It's going to be from A to B of f of x dx. That would find the area underneath the curve. What this theorem is stating is there is some rectangle. Oh my gosh, I just got a picture. Nico, be quiet. Where the area of this rectangle should be equal to the area underneath the curve. Okay, and what we're going to do, there's going to be some, Nico, be quiet. There's going to be some c value where f of c is going to be the height of that rectangle, and then b minus a, that's going to be the width. Okay, so this is the height, this is the width. The height times the width of that rectangle is going to be equal to the area underneath the curve. Okay? And this is known as the mean value theorem. Alright, so I just wrote that out there. Okay. So we just went through this, what I'm highlighting here. That is the mean value theorem. Okay. Now, if I would multiply both sides by 1 over b minus a. Okay. This right here, hopefully you can see that's going to be equal to 1. And then I would be left with this, where this would be f of c. This f of c, this is known as the average value. This is the height of the rectangle. So we can manipulate this equation if I want to just know the height of the rectangle for the mean value theorem. Okay. So manipulating it and getting it into this form here, that's known as the average value. Okay, so when when I have it in this form here, this is known as the average value. That's the height of the rectangle. The value of f of c given in the mean value theorem for integrals is called the average value of f on the closed interval from a to b. Okay, let's try one of these. So it says find the average value of the function. Find the average value of f of x equals 3x squared minus 2x on the closed interval. So to find the average value, f of c will equal 1 over b minus a, the integral from a to b of f of x dx. So f of c, that's your average value. This is going to be a, this is going to be b. So 4 minus 1 is 3. We're going to integrate this from 1 to 4. And f of x would be 3x squared minus 2x dx. This should be an easy integral for us to solve. 1/3. If the antiderivative here, this is going to be 3x cubed over 3 minus 2x squared over 2. Integrating that from 1 to 4. Let's simplify this and make this x cubed minus x squared from 1 to 4. Now let's plug in the limits of integration. So let's start with 4. So I'm going to have 1/3. 4 cubed would be 64 minus 4 squared would be 16. Okay. Minus, now let's do 1. 1 cubed would be 1 minus 1 squared would be 1. So this is going to be 1/3. This is going to be 48. And 1/3 of 48 would be 16. So the average value, which would be the average height of the rectangle, would be 16.